Hey guys, welcome to Kakao Academy channel. Igao is here, and today, actually tonight, I would like to talk about one really cool exercise that might be resolved by either applying recursion or also so-called dynamic programming. So the problem says a child is running up a staircase with n steps and can hop either one step, two steps, or three steps at a time. Implement a method to count how many possible ways the child can run up the stairs. So basically they say if we have three stairs, a child can take can cover two stairs at once. Then one stair, child also can start from one stair and then jump two stairs, or child can jump three stairs right away, or the child can take one step, then one more step, and then the third one, the last step. Okay. Important to mention that usually when people who ask you this exercise to be resolved, they do not mention this very important topic. So by default, you should assume that no, the order doesn't matter, because if you look right here, we can say that the child can either take first move as two steps and then complete the whole distance with one more step, or the same child can take one step, then two steps. So this is very, very important, otherwise you will simply take this exercise and its solution to wrong direction. So you have to take into account that order does not matter, and what you asked to do is to cover explicitly all the possible ways a child can cover the distance. In addition to that, does 0 steps mean one way? Yes. Basically, to better understand the problem, you should consider 0 steps. So basically, if I have a function calculate steps, which would take n steps into as a parameter. So the function should right away by default know that if n steps equals 0, we return 1. So basically by saying since number of steps equals to 0, there is only one way to cover the distance, by saying also like there is no way to cover this, so it's only 1. So programmatically we consider it to be 1. Same if we say if number of steps equals 1 again, so we have only one step and there is only one way to cover it by taking one step at a time, so we also going to be returning 1. Okay, and also to simplify ourselves life a little bit, we also say that if number of steps equals 2, that means we can either take one and another one, or we can take and cover 2 steps at a time. That means that if number of steps equals 2, we return 2. We have 2 ways based on the description of the exercise, cover the distance. Alright, so as I mentioned earlier, we can solve this we can solve this exercise by either applying Fibonacci sequence principle or dynamic programming. So let's start from dynamic programming first, and Later I'll show you how to resolve this task using the Fibonacci sequence. Alright, so since we have three possible variations of child's move, we're gonna create an array. I'm gonna call it ways, and we're gonna give it size 3. So by doing so, we say that we're gonna take into account options provided in the description of this task. So we have three options: 1 step, 2 step, or 3 steps. So since we already know that 0 steps result in one way, 1 step result in one way as well, and 2 steps result in 2 steps, we can assign these values accordingly. So we're gonna say that ways 0 equals, oops, sorry, my bad, ways 0 equals 1, ways 1 equals 1, and ways 2 equals 2. So as you can see, I can take these values from a table right here, and the further we go up the stairs, we can see that third element right here represents a sum of the first and the second, and let's say the child takes 1 step, so the child no longer here on step 0, the child right now on step 1, and what happens? The following thing happened. The first element just became second element from the previous group. The third element the second element became the third element from the previous group, and again the third element is a sum of first two. So let me show you how it works from a programming standpoint. Basically, we say that for int s equals 3, since we cover first 0, 1, 2, we're gonna start our loop from 3 steps, and obviously s would be less than number of steps, s plus plus. Here we say that we're gonna introduce a placeholder, some placeholder, okay, and sum of placeholder would be sum of all three elements, so it's gonna be ways 0 plus ways 1 plus ways 2. Okay, now as we said, first element of an array becomes second element of an array, and second element of an array becomes third element of an array, and the third element of an array becomes the sum of the previous block, so say some placeholder. Okay, and we're gonna do it every time a child moves on by taking more step and more step and more step. So that said, we still need to return the sum of all possible ways. So basically we say with each additional step we take the sum of possible variations for 0 steps, possible variations for 1 step, possible variations for 2 steps, and so on and so on. And in the end, what we need to return would be the very same thing. Okay, so let's try our code, and we know that 3 steps will result in 4 possible ways. So we say, so calculate steps 3. Let's see if we have our code running as expected. Yes, so it calculates it correctly. Just to be sure, I know that 4 steps should be resolved in 7 possible ways. Let's see if it works. Works as expected. Awesome. So this is a way to parse through the steps by incrementing possible variation for first step. Then we say with each more step that it simply adds up to the sum of possible ways, and that's also called a dynamic programming approach. Why it's the dynamic programming approach? Because instead of using nested loops, we use a single loop, where also with each iteration we introduce a placeholder. Alright, so this is one way of solving this exercise. Let's see how Fibonacci sequence can help us solve this exercise as well. The Fibonacci sequence approach is always, or at least in my honest opinion, seems to be way more elegant. However, you still do need to understand how the things are taken care of. So let's code it first and break it down later. So first of all, we're gonna keep these breaking points. As you recall, when we use recursion, we do have to provide default return values first of all, or breaking points also. Then what we say is the following, that calc steps of n steps minus 1 plus calc steps n steps minus 2. And if you recall from Fibonacci exercise, this would be it. But since we have a third option where we take 3 steps at a time, we also return calc steps and steps minus 3. Alright, so as we mentioned earlier, our expected result would be 7 ways. Let's see and run this one. Alright, looks like it's working. You see way less code, less readability as well, at least unless you are really familiar with recursion and applying Fibonacci sequence to such exercises. So let's double check ourselves and use 3 as a parameter. 4 ways, okay, as expected. So what do we do here? Basically, we use recursion and we say that if we have 0 steps then we have one way. If we have one step, it's still one way. If we have two steps, it's two ways. And with each iteration, so basically it would go 3 right here minus 1. What would it give us? It will give us 2. We know that for 2 it will return us two ways. 3 minus 2 will give us 1, and 1 will return us 1 way, and so on, so on. So basically it will go down all the way. It will add up all these options to the final result, which, as we saw, was 4. That's it for this tutorial. Thank you for watching, guys. I hope it was useful. I know this exercise, and especially the dynamic programming approach, might be a little bit confusing, but I hope that it made sense to you. Thank you for watching. Please like and subscribe. Stay safe. Bye bye.